Edward Rolf Tufte is an American statistician and professor emeritus of political science, statistics and computer science at Yale University. He is noted for his writings on information design and as a pioneer in the field of data visualization. Biography. Edward Rolf Tufte was born in 1942 in Kansas City, Missouri, to Virginia Tufte and Edward.E. Tufte. He grew up in Beverly Hills, California, where his father was a longtime city official, and graduated from Beverly Hills High School. He received a BS and MS in statistics from Stanford University and a PhD in political science from Yale. His dissertation, completed in 1968, was entitled The Civil Rights Movement and Its Opposition. He was then hired by Princeton University's Woodrow Wilson School, where he taught courses in political economy and data analysis while publishing 3 quantitatively inclined political science books. In 1975, while at Princeton, Tufte was asked to teach a statistics course to a group of journalists who were visiting the school to study economics. He developed a set of readings and lectures on statistical graphics, which he further developed in joint seminars he taught with renowned statistician Rolf Tufte, a pioneer in the field of information design. These course materials became the foundation for his first book on information design, The Visual Display of Quantitative Information. After difficult negotiations with mainline publishers failed, Tufte decided to self-publish Visual Display in 1982, working closely with graphic designer Howard Growler. He financed the work by taking out a second mortgage on his home. The book quickly became a commercial success and secured his transition from political scientist to information expert. On March 5, 2010, President Barack Obama appointed Tufte to the American Recovery and Reinvestment Tax Recovery Independent Advisory Panel to provide transparency in the use of recovery-related funds. Tufte is an expert in the presentation of informational graphics such as charts and diagrams, and is a fellow of the American Statistical Association. He has held fellowships from the Guggenheim Foundation and the Center for Advanced Study in the Behavioral Sciences. He is intensely critical in the self-editing process. He pulls in and casts out ideas from books, journals, posters, auction catalogs, and other less common sources. He invites others to critique his work in progress and may nurture dozens of ideas over months in various states of growth and fruition. He deletes almost every photograph he takes. Over time, he deletes most of what he writes on his own forum, ET-Netbooks. Every printing of every book corrects numerous small blemishes, ranging from color registration to kerning and inting. Information design. Tufte's writing is important in such fields as information design and visual literacy, which deal with the visual communication of information. He coined the word chart junk to refer to useless, non-informative, or information obscuring elements of quantitative information displays. Tufte's other key concepts include what he calls the life factor, the data-ink ratio, and the data density of a graphic. He uses the term data-ink ratio to argue against using excessive decoration in visual displays of quantitative information. In Visual Display, Tufte explains, sometimes decoration can help editorialize about the substance of the graphic, but it is wrong to distort the data measures, the ink locating values of numbers, in order to make an editorial comment to fit a decorative scheme. Tufte encourages the use of data-rich illustrations that presented all available data. When such illustrations are examined closely, every data point has a value, but when they are looked at more generally, only trends and patterns can be observed. Tufte suggests these macro-micro readings be presented in the space of an eye span, in the high-resolution format of the printed page, and at the unhurried pace of the viewer's leisure. He uses several historical examples to make his case. These include Jon Snow's cholera outbreak map, Charles Joseph Menard's cart figurative early space debris plots, Galileo Galilei's Sidereus Nuncius, and Ma Lin's Vietnam Veterans Memorial. For instance, the listing of the names of deceased soldiers on the black granite of Lin's sculptural memorial is shown to be more powerful as a chronological list rather than as an alphabetical one. The sacrifice each fallen individual has made is thus highlighted within the overall time scope of the war. In Sidereus Nuncius, Galilei presents the nightly observations of the moons of Jupiter in relation to the body itself, interwoven with the 2-month narrative record. Criticism of PowerPoint. Tufte has criticized the way Microsoft PowerPoint is typically used. In his essay, The Cognitive Style of PowerPoint, Tufte criticizes many aspects of the software. It's used to guide and reassure a presenter, rather than to enlighten the audience. Its unhelpfully simplistic tables and charts, resulting from the low resolution of early computer displays, the outliners causing ideas to be arranged in an unnecessarily deep hierarchy, itself subverted by the need to restate the hierarchy on each slide. Enforcement of the audience's lockstep linear progression through that hierarchy. Poor typography and chart layout, from presenters who are poor designers or who use poorly designed templates and default settings. Simplistic thinking, from ideas being squashed into bulleted lists, and stories with beginning, middle, and end being turned into a collection of disparate, loosely disguised points, presenting a misleading facade of the objectivity and neutrality that people associate with science, technology, and bullet points. Tufte cites the way PowerPoint was used by NASA engineers in the events leading to the Space Shuttle Columbia disaster as an example of the many problems. The software style is designed to persuade rather than to inform people of technical details. Tufte's analysis of a NASA PowerPoint slide is included in the Columbia Accident Investigation Board's report, including an engineering detail buried in small type on a crowded slide with 6 bullet points, that if presented in a regular engineering white paper, might have been noticed and the disaster prevented. Instead, Tufte argues that the most effective way of presenting information in a technical setting, such as an academic seminar or a meeting of industry experts, is by distributing a brief written report that can be read by all participants in the first 5 to 10 minutes of the meeting. Tufte believes that this is the most efficient method of transferring knowledge from the presenter to the audience, and then the rest of the meeting is devoted to discussion and debate. Small multiple. One method Tufte encourages to allow quick visual comparison of multiple series is the small multiple, a chart with many series shown on a single pair of axes that can often be easier to read when displayed as several separate pairs of axes placed next to each other. He suggests this is particularly helpful when the series are measured on quite different vertical scales, but over the same range on the horizontal x-axis. Sparkline. Although Tufte is said to have invented sparklines, in actuality he invented only the name and popularized it as technique. Sparklines are a condensed way to present trends and variation associated with a measurement such as average temperature as stock market activity, often embedded directly in the text. For example, the Dow Jones Index for February 7, 2006. These are often used as elements of a small multiple with several lines used together. Tufte explains the sparkline as a kind of word that conveys rich information without breaking the flow of a sentence, a paragraph made of other words both visual and conventional. To date, the earliest known implementation of sparklines was conceived by interaction designer Peterzell and implemented by programmer Mike Medved in early 1998. Sculpture. Beyond his academic endeavors over the years, Tufte has created sculptures, often large outdoor ones made of metal or stone, which were first primarily exhibited on his own rural Connecticut property. In 2009-10, some of these artworks were exhibited at the Aldrich Contemporary Art Museum in Ridgefield, Connecticut. In the one-man show Edward Tufte, Seeing Around, the Tufte Sculpture Garden in Woodbury, Connecticut is open to the public 1 day per year. In his sculpture, he digs through sources ranging from other art and other genres, to flea markets, nuclear power plants, and fields of grass. He is in search of forms and ideas from which to build models, table pieces, and occasionally larger landscape pieces. Even some nominally finished, large-scale works are reworked heavily, but at the same time, some random sculptural equivalents of brushstrokes or artifacts of a piece's former life are retained. A degree of wabi-sabi, as may be seen in rocket science. In 2010, the man known as E.T. opened a gallery, E.T. Modern, in New York City's Chelsea Art District, at 11th Avenue and 20th Street. The gallery closed in 2013 after 3.5 good years. Bibliography. Works on political economy, works of analytic design, exhibitions, visual explanations, prints and sculptures. 2001, New York. Artist's Space. Escaping Flatland, Los Angeles, Architecture Plus Design Museum, the 7th of November 2002 to 13 February 2003. Seeing Around, June 13, 2009 to April 11, 2010. Ridgefield, Connecticut, Aldrich Contemporary Art Museum.